I've got a question for you. A student investigates how a spring stretches when a force is added. Okay, look at the graph of his results. Well, that's telling me to do something. Okay, I'll look at the graph of his results. I've got a graph of force, I've got a graph of extension, and I've got a straight line through the origin. Okay, where are we going with this? Oh, I see. Calculate the spring constant of the spring. And down here, spring constant equals newtons per metre. That's worth looking at. Okay, and I'm going to get 3 marks if I get all of this right. Cool, I could do a 3 marks. Okay, well this sounds very much like a QUENS problem. Okay, so let's just do this. QUENS. I'm going to put it there because that's where the most space is. I'll try and write small enough to fit all this in. So identifying quantities, very, very important. What does the question give me? What information have I got? Well, it hasn't given me any numbers in the writing. Okay, but they have given me a graph. And I'll tell you what, if they give you a graph in the question, you're going to have to use it. They don't put it there for fun. So if you don't get something from the graph or do something with the graph, you're probably not doing what they want you to do. So it's a very nice graph. They spent a lot of time getting that nice. Okay, and there are there's lots of information that you can get from a graph, especially quantities. Now, spring constant of the spring, I remember that is K. Okay, we're talking about a force being added, oh that's an F, and a spring that is stretched because of a force has been extended. We're talking about extension, and I'm going to use the letter X for that. Okay, so on the graph, there's my force, there's my X, K is the question. I've got 3 things going on here. I've got F, K and X. Now, what values can I get? If I'm going to calculate something from this graph, the graphs will tell you various things. You can read off the y-axis, in this case force, you can read off the x-axis, in this case extension, but you can also calculate things like the gradient. The gradient will often give you a quantity, so the gradient is a quantity. Okay, and sometimes you need to calculate the area under a graph. Okay, because that gives us another value. So we need to remember all those things. What can I do with the graph? Now, what does the gradient give me? The gradient, remember, is the change in y divided by the change in x. You might know that as rise over run. Okay. In this case, the gradient is going to give me force divided by extension. Force is measured in newtons, extension is measured in meters, and look at the answer line, newtons divided by meters. That's telling me the equation that I need to use. That's telling me newtons divided by meters gives me the gradient of the graph, so I need to actually calculate the gradient of the graph. So it's a straight line graph. It doesn't really matter what change in y versus change in x I could use. I could use, look, if I look at force equals 1, well, the extension is about 0.05, but it's very imprecise to use a small bit. I've got this nice long straight line up here. I might as well use the whole line. I'm going to use force equals 5. Okay, I can use a ruler, but I can't find it because I've come to the exam without a ruler. What an idiot. Okay, I'm going to use a ruler and carefully read across the graph until it hits the line, and then I can drop down and see what value of extension I've got. Well, F equals 5 newtons because that's where I've chosen to go to, and oh, that's nice, it's right on the line. The extension equals 0.2 meters. Okay, I'm using the units that's given to me. 5 newtons, 0.2 meters. There are values and quantities in the question, it was just hidden in a graph. Okay, spring constant K is the unknown value. The units are going to be newtons per meter. I'm going to write it up here because I want to have all my information in a nice neat line so I can see it clearly. Okay, now my question is just written down here and I don't have to worry about all this blurb. Okay, units, just check them. Newtons is fine, meters is fine, and they match the answer line. So I've checked my units, I don't get any marks for doing conversion, I don't need to. The equation is given to me by the answer line, but I can check with my equation sheet. Okay, springs are to do with forces, it's going to be in the forces section. I've got F, K and X in my quantities. I need an equation that's got F, K and X in it. Oh look, there's one. F equals Kx. I'm going to write that down because that's my methodical approach using QUENS. I'm going to change now my number, all these letters. I can, if I know them, I can put the number in instead. F, well I do know that, that's 5. So 5 equals, don't know K, 5 equals something multiplied by 0.2. Okay, I need to rearrange this to get K on its own. I need to divide both sides by 0.2. If I divide 0.2 by 0.2, it cancels out. I've got to do the same on that side. So K equals 5 divided by 0.2. I could write that out again here. I'm writing bigger than I normally would just for the video really, so obviously you'll have a bit more space if you're not writing quite so big as me. 5 divided by 0.2 equals 25. And it's going to be 25 newtons per metre. I'm going to put my answer on the answer line here and underline it just to show the examiner that that is my answer. 3 out of 3. Happy days.